In this video, we'll explain what the longitudinal center of gravity is, why it is important, and how it can be determined. We'll also explore its relationship with the longitudinal center of buoyancy and how this affects the ship's trim. The longitudinal center of gravity, LCG, is the longitudinal distance, either forward or aft, from a chosen reference point, typically from midships or from the aft perpendicular. Now, when a ship is placed in water, it is acted upon by two main forces. First, the vertical downward force, known as the gravitational force, which is equivalent to the ship's total weight. This force acts vertically downward through the ship's center of gravity, represented by capital G. Next is the upward vertical force, known as buoyancy force. This force is equal to the weight of the water displaced by the immersed ship. It acts vertically upward through the centroid of the displaced volume of water, called the center of buoyancy, denoted by capital B. For a ship to float in equilibrium, these two forces must be equal in magnitude, and act in opposite directions along the same vertical line, typically along the ship's centerline. Consider a ship floating at rest in still water. This is viewed as a longitudinal section, floating on an even keel, and this is her transverse section, viewed as a cross-sectional slice across the ship's width, from port to starboard. Let's assume that the ship's center of gravity is here, along the centerline. The vertical distance measured from the keel to the ship's center of gravity is called kg, or VCG, vertical center of gravity. kg is used in transverse stability calculation. On the other hand, the longitudinal distance of the ship's center of gravity, forward or aft, from a chosen reference point, often from midships, or from aft perpendicular, is called LCG, longitudinal center of gravity. LCG is used in trim calculations. So when we refer to the ship's kg and LCG, we are talking about the same center of gravity, just measured in different directions. kg is measured vertically, while LCG is measured longitudinally. Suppose the ship's center of gravity is here. In that case, the center of buoyancy, B, will lie vertically below G. A gravitational force acts vertically downward through G, while an equal buoyancy force acts vertically upward through B, in the same vertical line. In this condition, the ship is floating in equilibrium, displacing her own weight of water. Now, let's assume a weight already on board is shifted aft by a certain distance. This movement causes the ship's center of gravity to shift from G to G1, in the same direction and parallel to the movement of the weight. This creates a trimming lever, producing a trimming moment, which is equal to the weight shifted, multiplied by the distance it was moved. As a result, G and B become separated, creating a trimming lever, which causes the ship to trim by the stern. The ship continues to trim until the center of buoyancy shifts to a new position, B1, which lies vertically below the new center of gravity, G1. The point of intersection between the two verticals through the longitudinal positions of the center of buoyancy, B, and B1 is called longitudinal metacenter, ML. These verticals represent the directions of the buoyancy force before and after shifting a weight. The vertical distance between the new center of gravity, G1, and the longitudinal metacenter, ML, is called longitudinal metacentric height, GML. In this case, after shifting a weight, the ship's LCG changes. To determine the distance between G and G1, we divide the trimming moment by the ship's displacement. I have here a sample of manual calculations used to determine the ship's final displacement, the longitudinal center of gravity, LCG, the trimming moment, the vertical center of gravity, kg, the vertical moment, and other related values. Let's focus on the column of LCG values. As we observed, each compartment on the ship has a corresponding LCG, such as fuel oil tanks, ballast tanks, and cargo holds. These LCG values can be found in the ship's stability booklet. Now, let's take a look at the LCG values for the cargo holds listed in this example. We can find it in this column. For cargo hold number 1, the LCG is negative 46.84 meters. Cargo hold number 2, negative 26.90 meters. Cargo hold number 3, negative 7.27 meters. Cargo hold number 4, positive 12.25 meters. And cargo hold number 5, positive 32.54 meters. For the ballast tanks, from number 1 to number 3, the LCG values are negative, while those for tank number 4, the duck keel, and the after peak tank are positive. As I mentioned earlier in this video, the LCG is the longitudinal distance, either forward or aft, from a chosen reference point, typically from midships, or from the aft perpendicular. If the LCG values include both positive and negative, the reference point is usually midships. If it is noted by this acronym, meaning forward of aft perpendicular, the reference point is the aft perpendicular. In this case, since the LCG values include both positive and negative, the reference is midships. To determine whether a particular LCG is forward or aft of midships, we simply look at the physical location of the compartments using a ship's plan. Cargo hold number 1 is clearly located forward of midships, and its LCG is negative. Cargo hold number 5 is located aft of midships, and its LCG is positive. The forepeak tank, located forward of midships, also has a negative LCG. Meanwhile, the after-peak tank, located aft of midships, has a positive LCG. This confirms that in this particular given data, LCGs with negative values are located forward of midships, while LCGs with positive values are located aft of midships. Let's now take a look at another loading plan, extracted from the stability booklet of a different ship. We can find the LCG values listed in this column. This ship also has 5 cargo holds, but this time, the LCGs of cargo holds 1, 2, and 3 are positive, while the LCGs of cargo holds 4 and 5 are negative. Based on these values, we can observe that positive LCGs are located forward of midships, and negative LCGs are located aft of midships. This arrangement is the reciprocal of what we saw earlier. Usually, for a Japanese-made vessel, it is common that negative LCG values indicate positions forward of midships, and positive values indicate aft of midships. I will cover how to manually calculate the ship's final LCG in a separate video. That's all for now. I hope you found this video helpful. Thanks for watching. I'll see you in the next one. Bye for now.